objective of this video is to classify triangles by the lengths of their sides and the measure of their angles. Also, to apply facts about triangles to obtain unknown measures of angles. First, let's talk about classifying based on angles. If all of the angles inside of a triangle are less than 90 degrees, then they're all acute angles, and therefore you have an acute triangle. If one and only one angle inside of a triangle is 90 degrees, shown by this little square here, then you have a right triangle. If one and only one angle inside of a triangle is obtuse, meaning greater than 90 degrees, then you have an obtuse triangle. Now, when you classify triangles, you not only classify them by the angles, you also classify them by the lengths of their sides. Now, when it comes to showing lengths of sides without actually giving real numbers for lengths, mathematicians use these little tick marks. And there's no value to these tick marks. It only says that when you've got one line, it means that's one length. When you have two lines, it's different than the one line. When you have three lines, it means it's different length than the other two lines. It doesn't necessarily mean that the number 2 line is bigger than the number 1 line, or the 3 lines bigger than the number 1 line. It just means there are different lengths. As you can see, this line is actually smaller than the other two, and yet it's got the three slashes through it, or I call tick marks. So what this is saying here is that all 3 sides are not the same length. No congruent sides. Remember, congruent means equal, same length. So a scaling triangle has no sides that are the same length. An isosceles triangle has 2 sides that are the same length. And, as it turns out, 2 angles will be congruent as well. And those 2 angles are going to be the ones that are opposite of the sides that are equal. This angle is opposite of this side. This angle is opposite of this side. So those 2 angles are the ones that are going to be equal in an isosceles triangle. Equilateral triangle. When you've got an equilateral triangle, all 3 sides are the same length and all 3 angles are the same measure. So all 3 angles same measure, all 3 sides the same length makes an equilateral triangle. So let's take a look at these 2 triangles and classify them. Looking at this one, first thing I note is the angles. I see a 90-degree angle, so we know this is a right triangle. I also see that there's 2 sides that are equal, so it is an isosceles triangle. So together forms a right isosceles triangle. Over here, looking at this, I see 2 lengths that are the same. So I know I've got another isosceles triangle. But then the question becomes, is it scaling? Or it's not scaling, it's definitely isosceles. Is it right, acute, or obtuse? Well, these 2 are definitely less than 90 degrees. But this one's not. This one's greater than 90 degrees, which makes this an obtuse isosceles triangle. And that is how you would classify them. By angle, by lengths, and a triangle on the end. 2 you-dos, pause the video, give them a try. Welcome back. All 3 sides here are not equal in length, which means that this is a scaling triangle, and we do see the right angle there, so it is a right scaling triangle. Do not abbreviate RST or anything like that. Write it out. This one, all 3 sides are the same length. All 3 angles are the same. We have an equilateral triangle. Now, you may be thinking, well, what about the length and size? You only have one thing there. Well, as it turns out, the equilateral triangle will always have 60 degrees for each angle. So there is no other way. It cannot be an obtuse, because there's no way you can have an obtuse and equilateral. You can't have a right and equilateral. So, true, this is a acute equilateral triangle, but generally they don't force you to include the acute in the description because it's understood that equilateral triangles can only be acute. They can't be right or obtuse. So in this case, you would just have equilateral triangle. Okay, at this moment I want you to get a piece of paper, take a moment, get a piece of loose leaf paper or other paper and cut a triangle out of it. Triangle can be any size, any shape, any kind of scaling, right, whatever, just cutting a triangle. So I'm going to go like this. I'm just going to make this simple. I'm going to cut right across here. And there's my triangle. Once you got a triangle, take one corner, any corner, rip it off, hold on to it. Take another corner, rip it off, hold on to it. Now you see I've got those 3 points there, 1, 2, 3. These are the 3 points. If I take those 3 points and I arrange them together, holding them together, lining them up on the edges like that, boom, boom, and boom. You'll notice that I form a straight line. And how many degrees are there in a straight line? A straight angle has 180 degrees. Yours should have come out to a straight line too. It doesn't matter what size the triangle, whether it's right triangle, scaling triangle, isosceles triangle. When you take those 3 angles, those 3 interior angles, and you add them together, you're going to get a total of 180 degrees. In words, the sum of the measures of the angles of a triangle is 180 degrees. Algebraically, that's x plus y plus z is equal to 180 degrees. Therefore, given the measure of any 2 angles of a triangle, you can calculate the missing angle. So if you know 2 of them, you can find the 3rd. Example. Now, at first you may be looking at this thinking they've only given us 1 degree. Remember, though, that that square indicates that that is a right triangle, which means that is a 90-degree angle. So they gave us 2 angles. We can find that missing 3rd by using the formula x, that one angle, plus the 60 plus the 90 is going to add up to 180. Add these 2 together, I get x plus 150 equals 180. Subtract 150 from both sides to solve for x. You end up getting x is equal to 30 degrees. Over here, we have x plus 45 plus 45 is going to be equal to the 180. 45 and 45 add together to give me 90. That's called combining like terms. Little vocabulary there. Then to get rid of the 90, we subtract 90 from both sides, and we get x is equal to 90 degrees. Now you'll notice that the picture shows it's not perfectly 90. That's going to happen. Many times on questions, they're going to give you the picture that's a little misleading. It's close to 90, doesn't really look like 90. You can't judge by the picture itself. You can't look at it and say, that's definitely not 90, I must have the wrong answer. This time, you have to work with the numbers. All right? The way to learn math is to do math, 2 you-dos. Pause. Welcome back. All right, here we have x plus 95 plus 30 is going to equal 180. 95 and 30 add together is going to give me 125. X plus 125 is going to equal 180. Subtract 125 from both sides, and you're going to get x is equal to, what is that? 45 degrees, I think? No, 55 degrees. 55 degrees. Don't forget the degree symbol on your answer. That is the units for your answer, and you should include units with all answers. All right, here we have x plus 120 plus 45 is equal to 180. Let's say you don't like the idea of adding these together first, and you want to solve another way. I could subtract the 120 first and get rid of that, which would give me x plus 45 is equal to 60. Then I could subtract the 45 from both sides, and I get x is equal to 15 degrees. Okay, now you may be asked a question like this. The measures of angles of triangle ABC are in the ratio 3, 4, 5. What are the measures of the angles? Now, we've dealt with ratios before. When you've got a ratio like this is actually a 3 ratio thing, which you would not really work with. But what they're saying is, for every one something I have, I got 3 on one side, 4 on the other, 5 on the other. It's 5 multiples. So there is a connection between each of the lengths of each side. And if you did 3 times this unknown part of the ratio, plus 4 times the unknown part of the ratio, plus 5 times the unknown part of the ratio, you would get a total of 180 degrees. You're basically taking these 3 numbers and putting them into this equation, 3x plus 4x plus 5x. Something times x plus something times x plus something times x is going to give you that 180. Combining like terms, 3, 4 is 7, plus 5 is going to be 12. That's how I get the 12x. Then I would divide both sides by 12, and I get x is equal to 15. Now, that's not the final answer, because it didn't ask us what x was. It asked us what are the measures of the angles. So, since x is 15, the sides have lengths of 3 times 15, 4 times 15, and 5 times 15. These 3 numbers times our x value. 3 times 15 gives us 45 degrees. 4 times 15 gives us 60 degrees. 5 times 15 gives us 75 degrees. If I've done everything correctly and I add all 3 of these together, I should get 180 degrees, because that's the sum of the angles and triangles. If not, I made a boo-boo. We're going to want to go back and check it over. But 45 to 60 is 105, plus 75 gives me 180. So I've got the right answer there. You do. The measures of the angles of triangle XYZ are in the ratio 1, 3, 5. What are the measures of the angles? Pause. Welcome back. You're going to have 1x plus 3x plus 5x is equal to 180. Adding these together, 1 plus 3 is 4, plus 5, I get 9x equals 180. Divide by 9, and I'm going to get x is equal to 20. So my angles are going to be 1 times 20, which is 20 degrees, 3 times 20, which is 60 degrees, and 5 times 20, which is 100 degrees. Adding those all together, I do get 180 degrees, so that's my double check. There's my 3 answers. See you in class.